Okay, the cut was not so good, so let's do it again. Okay. Okay, let's now run again for the 30. It was more or less the same, which means that I may have some saturation in this photo transistor. So what I will do, I will try to decrease the voltage here. Okay, 4 volts. 4 volts, I have somewhere around 0.2. And now if I compare with this one, so it was still a little bit higher, so that means I have I have some losses in this fiber. So we'll do this with more care in the lab. Okay, so now we can send these signals to the spectrometer. So we'll do for each LED, we will measure the spectrum. So I can come here, and now I have to be a little bit careful with this spectrometer. So let's try to put the fiber in the entrance, but do not push till the end, so just leave like that. And this spectrometer, there's a switch in the back, so we will turn on to the USB mode here. So we turn this on, so the power on LED here is on. And now we can open the software. It's this AvaSoft 7.5. Okay, the spectrometer was connected. And now let me decrease the number of averages to 1 and let me start. Okay, so I have some background from the room. Okay, so this power is too high, so I'm saturating the detector, so let me change to 2 milliseconds of integration time. All right, and you see here the spectrum of the LED. So I can actually increase a little bit more here. Let's say 4 milliseconds. I would double the signal. So I still have some room to improve. With that, I increase the signal to noise ratio. Okay, I can click here, and then I can measure the peak. So I can click on this tool here, this show cursor, and then I can drag this, and the wavelength will appear here on the top. So this was 473 nanometers. And of course you do for each LED from red to infrared. So for example, if I change from here to here, this should be an infrared LED. so I won't be able to see with my eyes. Maybe you can see with this camera. And then if I place it here, now let's start and see. So now we have an LED which emits light centered